Alright, I'm going to run through an example now of a quadratic function in vertex form. Okay, so you can see this is in vertex form. It's in the a times x minus h squared plus k format. And I've got a list of things that we're going to try to find based upon that equation. So I want to find the vertex, whether it opens up or down, axis of symmetry, the y and x-intercepts, the point symmetric to the y-intercept, the domain, the range, the standard form, and the graph. So all these things are things that we can find just simply based upon that equation. We'll start out with a vertex. Remember, the vertex is always h comma k. And if this is in vertex form, then the h is the opposite of the sign in the parentheses, so it's 3, positive, and the k value is the negative 2. Right? So we can find the vertex very easily. It's h comma k, which in our case would be 3 comma negative 2. Again, this is why it's called the vertex form, because the vertex is immediately seen right from the equation. Now the direction in which this opens, remember, with an a value that is positive, is going to open up. Because the a value is positive, okay? That's the key. Alright, so it's going to be opening up. It's got our vertex shifted right 3 and down 2, okay? 3 comma negative 2. Axis of symmetry. Well, axis of symmetry is always going through the x coordinate of the vertex. So that is going to be x equals 3. And remember, with the axis of symmetry, you always want to use an equation here. It's always x equals a number. That gives you your vertical line. Okay. The y-intercept, not too bad. All I got to do is plug in a 0 for x, right? So for the y-intercept, we're looking for f of 0, which is 1/2 of 0 minus 3 squared minus 2. If I evaluate that thing, 1/2 of, well, negative 3 squared is going to be positive 9, so it's half of 9 minus 2. Half of 9 is 4.5. 4.5 minus 2 is 2.5. So our y-intercept is at 0 comma 2.5. So we're cruising along. The first few things are pretty quick. The x-intercepts, that's going to be a little bit more work. So for the x-intercepts, you've got to replace the function value with 0, the output. So you get 0 equals 1/2 times x minus 3 squared minus 2. Well, I'm going to solve this for the x. So I'm going to start off by adding the 2 to both sides. You get 2 equals 1/2 of x minus 3 squared. Next is to get rid of the half. So I'm going to multiply both sides by 2. Right, so that'll cancel the half off. This would give me 4 on the left. 4 equals x minus 3 quantity squared. I use the square root property here. Some people say they take the square root of both sides, but you just have to remember to use a plus or minus on this constant. So it would be plus or minus the square root of 4 is equal to x minus 3. At this point, I'm going to take this over to the side a little bit more. I'm going to evaluate that square root of 4. So that's really plus or minus 2 equals x minus 3. And when I add the 3 to both sides, I get positive 3 plus or minus 2. So it gives me 2 different answers. Okay, one with a plus, one with a minus. In fact, I'm going to give myself a little more space right there. 3 plus or minus 2. Okay, so with the plus, 3 plus 2 gives me 5. And with the minus, 3 minus 2 gives me 1. That didn't show up well. Okay, so 5 and 1 are going to be the two x-intercepts. So I'm going to put those over here. So it's at 5, 0 and 1, 0. Now notice that the vertex of 3 and the axis of symmetry, those occur exactly halfway between the two x-intercepts. Okay, interesting point. Okay, so that gets me down through the x-intercepts. Now the point symmetric to the y-intercept. Remember that when you have a graph, and this does open up, when you have a graph, just a rough sketch like this, the axis of symmetry cuts this thing in half. Wherever the y-intercept is, the distance from there to the axis of symmetry is whatever h is. In our case, it's 3. Right, so this would be a jump of 3 over to the right. Well, to get a symmetric point, you double that. You got to go another 3, which is a total of 6 units over. Okay, so the point, maybe I need a little more space up here to pull this off. So the point symmetric to the y-intercept. Well, remember that is always going to be found using the formula 2h comma then the y-intercept, whatever that is. Okay, so the x value is 2h because you have to go over twice the h value, and then the height is the same as that y-intercept. So in our case, the 2h would be 2 times 3, which is 6. The y-intercept, if I go down to that point, that was at 2.5. So it's 6 comma 2.5 for the y-intercept. Okay. Or I'm sorry, for the point symmetric to the y-intercept. Okay. Now we're looking for the domain and the range. Well, the domain is the easiest thing up here probably. Domain is always all real numbers. No thought involved in that one. Quadratic functions, always all real numbers, because you can plug any number into a quadratic function and all of these operations are valid under any number. Okay. Now for the range, remember, is going to be the minimum point, because this graph does open up. It's going to be the minimum up to infinity. Well, that minimum is the y coordinate of the vertex, right? This graph is going to go down to -2. So the range is going to be from -2 to infinity. Okay, and now I don't really want the graph in here. We're going to do a much more precise graph in just a moment. The standard form is kind of interesting. You can convert from standard form to vertex form and back. Now the standard form in this case is found simply by expanding this expression. So if I took 1/2 times x minus 3 squared is really x minus 3 times x minus 3. If I were to distribute that, you'll find the x minus 3 squared to become x squared minus 6x plus 9. Okay. From there I distribute the 1/2, so I get 1/2 x squared minus 3x. Half of 9 is 4.5. And then the -2, and I simplify at the end. 1/2 x squared minus 3x plus 2.5. Now notice the 2.5 down in the end, that's our y-intercept. Okay. And this would be then the standard form. A is 1/2, B is -3, C is 2.5. Right? So last thing to do is to plot all of this. yeah, we are going to be a little short on space here, so I'm going to erase my standard form and the domain and range because those don't actually show up real well on the graph. There's not much I can't really plot those. And I'm going to get rid of my work on the X-intercepts here, just so I have a little more space. I can do that without ruining anything. All right, everything else can be plotted. So your vertex, axis of symmetry, Y-intercept, X-intercepts, and the point symmetric to the Y-intercept. So I'm going to start this off, and I already know kind of what it looks like, or at least I have a good idea based upon what I just sketched. I know the vertex is at 3, -2, and as I look at all these numbers, the largest number up here is the 6 that I'm going to have to plot. So maybe I go, maybe in the positive direction, I just go to 8 to make sure that I can hit everything. Give myself a little bit of space. So we'll hit 8 up there, and we'll hit 8 over there, and then we'll just cut those down. So there's 4, and there's 4, cut it in half. Cut that in half is 6, cut that in half is 2, and then half, 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 and half. Okay, so that should give me pretty good scale vertically, and then we'll do the same thing here. I'm going to put in all my even numbers, and then the odds go halfway in between. I should throw some negatives in here just to make sure. I do definitely need a negative on my Y value. So we'll try to keep the scale relatively consistent. Okay, something like that. And so now it's just a matter of plotting everything, right? So I've got 3, -2. We'll go over 3 down 2. There's a point on the graph. I know it's going to open up from there. The axis of symmetry is x = 3, so that's a vertical line. Ooh, that's not very vertical. There we go. Alright, something like that. That's my axis of symmetry. I should label that. I'll just write x = 3. Then my Y-intercept is here at 2.5. Right, so I can plot that in. And we'll call that 0, 2.5. Technically, I like to have the ordered pairs next to each point. The X-intercepts are 5 and 1, so I can plot those. 1 and 5. Oh, there's 1 and 1 and 1 and 5. I should write the ordered pair in. So 1, 0 there, 5, 0 there. And then finally the point symmetric to the Y-intercept is at 6, 2.5, and that makes sense because you go over 3 and then 3 again, but you go up to the same level. Okay. So in most of these problems you're going to be able to plot 5 points and the line of symmetry. However, it is possible that you don't have X-intercepts, in which case you would only end up with 3 points and the axis of symmetry, but still enough information to get a pretty good sketch. So at this point, I'm going to sketch it in. And my graph should look something like that. Okay, it's not perfect, but it's going to hit, at least the 5 points I put up there. Okay, so that does give you an idea then of how to find all the different pieces of information based upon a vertex formula, and then how to sketch the graph based upon that information you just found.